different quantum numbers, and it is named as principal quantum numbers, azimuthal quantum numbers, magnetic quantum numbers, and also spin quantum numbers. This sign which gives the information only about the probability of finding the electron, where electrons are revolving around the nucleus. Principal quantum numbers, which gives the information about the shell or the energy level to which the electrons are revolving. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called structure of atom. Under that, we already discussed about the de Broglie, the concepts of dual nature of matter. And also we discussed about the Heisenberg uncertainty principle. Under that, we have understood that it is not very easy to determine simultaneously the exact position and the exact momentum of an electron. Today, let us move on to the next topic of this unit about the quantum mechanics. So, in this session, we are going to understand more about the quantum mechanical model of an atom, and also we are going to understand more about the quantum numbers. So here we are going to understand the 4 different quantum numbers, and it is named as principal quantum numbers, azimuthal quantum numbers, magnetic quantum numbers, and also spin quantum numbers. Let's see their significance and how to represent this quantum number. Let us understand now. So before going to discuss with the quantum number, now let us see what is a quantum mechanics. Quantum mechanics, it is a theoretical science that always deals with the study of motion of a microscopic object that behaves both wave-like nature and a particle-like nature. Remember, it is a theoretical science that deals with the motion of a microscopic object that have both wave-like and a particle-like properties. So, in the quantum mechanics, we are going to understand the wave nature and the particle nature of the matter. Now, let us see some of the main important features of the quantum mechanical model of an atom. According to this, it states that the atom which consists of positively charged center, that is known as nucleus. Suppose imagine this is an atom which is present in any matter which consists of positively charged center, that is known as nucleus. That is known as nucleus. Okay? And electrons are present around the nucleus as a 3-dimensional standing waves, and the standing waves are confined in a region. And around this nucleus, the negatively charged particles will be moving in a circular path, and it is known as electron, and these electrons are always moving in a 3-dimensional wave-like motion. Then the energy and the trajectory of an electron wave in an atom was given by Schrödinger wave equation, that is H psi, which is equal to E psi, where psi is a wave function, E is a total energy of an electron, and also H is a Hamilton constant or the Hamilton operator. Okay? Remember, according to this, we have understood that we are dealing with the main important postulates of the quantum mechanical model of an atom. According to this, first postulate says that in an atom, always there is a positively charged center will be there. We call them as a nucleus. And around this nucleus, the electrons are moving in a 3-dimensional wave-like motion. And if you consider the energy and wave properties of that electron was related by using Schrödinger wave equation, that is Hψ is equal to ESI, where psi is a Hamilton operator, E is the total energy of the electron, and it is also known as a wave function. This is also known as wave function. Then, although the psi is a mathematical function and it is unobservable, the psi gives a probability of finding the electron in a small volume around the nucleus. So, suppose if you want to calculate the exact value of the psi which is moving around the nucleus, this psi which gives the information only about the probability of finding the electron, where electrons are revolving around the nucleus. And this psi will always having the both positive and negative values. And this psi can also be determined, that is the wave function can also be determined by using three variables, and it is also known as quantum numbers, and it is represented as N, L and also with the M. Okay. Now, we'll understand what is N, L, M later in the quantum numbers. Okay. The wave function with the three variables specifies the energy, shape of the orbital and orientation of the orbital of an electron. So, by using this psi, that is a wave function, that help us to calculate or help us to find the probability of finding the electron. Is it right? It also used to know the quantum numbers, that is N, L and M. That N, L and M that gives the energy, shape and orientations of the orbital in which electrons are revolving. So, this complete information about the electron was given by the quantum mechanical model of an atom by using psi, that is the wave function. Hope you all understood with all this postulate are the all important features of the quantum mechanical model of an atom. Now let us understand what is the quantum number and why we use the quantum numbers to know more about the electron. Let us understand now. Suppose if I want the complete information about the electron, maybe in the form of their energy, maybe in the form of shape, maybe in the form of orientations of the electron, maybe in the orientations of the orbitals, that can be understood by using the quantum numbers. Then this quantum numbers which consists of four important numbers, and it is known as principal quantum numbers, azimuthal quantum numbers, magnetic quantum numbers and spin quantum numbers. Remember, the first one, the principal quantum number, which always tell us the shell to which the electrons are belonging. Whereas azimuthal quantum number which gives the information about the subshell. Whereas a magnetic quantum number which helps us to know about the orbitals. Whereas a spin quantum number which explain the spin of the electron. So, by using all four important quantum numbers, we can easily determine the exact information about the electron. The complete information about the electron that can be obtained by studying these four important quantum numbers. They are the principal quantum number, azimuthal quantum number, magnetic quantum number and a spin quantum number. Now let us take with the principal quantum number. What is that principal quantum number? How do we determine the shells by using that? Let us understand now. Okay. The principal quantum number can be represented by using small n. Okay. And this principal quantum numbers, which gives the information about the shell or the energy level to which the electrons are revolving. Okay. It can be represented by n is equal to 1, 2, 3, so on. And if n is equal to 1, we call it as a k. And if n is equal to 2, we call it as a L. If n is equal to 3, we call it as a M. If n is equal to 4, we call them as a N shell. Like this, if you write the structure of an atom, at the middle, we all know that there is a positive charge center will be there, followed by the values of the N, that is 1. If N value is 1, obviously it become a K shell. If N value is 2, then values of the named as a L shell. If n is equal to 3, then we call it as a M shell. If n is equal to 4, we call them as a N shell. Okay. After knowing this number of shell, we need to know that how many electrons can be filled to the each shell. How maximally we can fill the electrons to the each shell can also be obtained by using a formula called as 2n square. 2n square, where the n represents the shells, okay, number of shell. Suppose if n is equal to 1, then the entire equation will become 2 into 1 square, it will become 2. So it is nothing but in the K shell, only 2 electron can be filled. So the K shell can accommodate only 2 electron. Suppose if n is equal to 2, then entire equation will become 2 into 2 square. So it is 2 into 4, so it will become 8. That is, in the L shell, we can fill the maximum of 8 electron. Understood? So in the K shell, only 2. Whereas in the L shell, there are 8 electron can be filled. Similarly, if n is equal to 3, by using that maximum number of electron can be filled, that is 2n square, we come to know that there are 18 electron can be filled in n shell. Similarly, for the n shell, 32 electron can be filled. So these are the main important bases that we must know, that within atoms, there are many number of shells will be there, and each shell will be named as K, L, M, N according to the principal quantum number, and each shell has their own capacity to hold the number of electron. That is, the K shell having a capacity to hold only 2 electron, whereas L shell can accommodate only 8 electron, whereas the M shell can accommodate only 18 electron, whereas the N shell can accommodate 32 electron, not more than 32. Hope you are understood with this concept. And also here, this principal quantum number, which also gives the information about the distance of an electron from the nucleus to the outermost shell of an atom. The distance of the electron from the nucleus to the outermost shell of an atom, that is also predicted by using this principal quantum number. And one thing I like to say that by using this principal quantum number, we can also determine the number of orbitals. Number of orbitals can also be obtained by using a formula called as n square, where n is a number of orbitals. Okay. Suppose if n is equal to 1, then it belongs to the K shell, where the K shell which consists of only one orbital. Whereas if n is equal to 2, then it will become 4. That is, the L shell which having 4 orbital. Similarly, the M shell will having 9 orbital, whereas n is equal to 4, then N shell will having 16 orbital. By this, we can clearly understand more about the shells, more about the orbitals. That is, the number of orbitals present in the each shell can also be obtained or can also be informed by using principal quantum numbers. Hope you all understood with this concept. Now let us go for the next one, that is azimuthal quantum numbers, which is also known as subsidiary quantum numbers, or also known as orbital quantum number, and it is denoted by small l. And this azimuthal quantum number, which gives the information about the subshell within the shells, and which also gives the information about the angular momentum of an electron and the shapes of the various orbital, and also it gives the information about the energy of the orbital in the multi-electron atoms. Suppose if you consider the carbon and also with the nitrogen, oxygen, in all those elements, the number of electrons are more and more as compared with the hydrogen. In such a situation, the energy of an orbital can also be understood by using this azimuthal quantum number with the principal quantum number. And the number of orbitals in the subshell was obtained by the relationship, that is 2l plus 1. By using this relationship, we can easily determine the number of orbitals in a subshell. Number of orbitals in a subshell is obtained by this relation, that is 2l plus 1. And for a given values of the n and l that have a n values ranging from 0 to n minus 1, and total number of subshell in a particular shell is equal to the values of the n. By using these relationships, how to find out the values of the n and along with the subshell, let us understand now. Okay. Usually, this azimuthal quantum numbers which having a capacity which will be started from, the values of the L will be started from 0, 1, 2 and 3. If it is there, if the values of the L is 0, then it indicates that the number of orbital is only 1 and it belongs to the s orbital. It belongs to the s orbital. Suppose if L is equal to 1, then which indicates that number of orbital is 3. Then it shows that the p orbitals, it belongs to the p orbital, where we have understood that the s orbital we represented with a single block, whereas the p orbital we represent with the 3 blocks, that is px, py and pz. Is it right? The p orbital we will be having 3 orbitals, okay, because the L value will be 1 and the number of orbitals will become 3. Similarly, for the d orbital, the values of the L will become 2, so that it belongs to the 5. There are 5 orbitals will be there in the d orbital and it can be represented as dx square minus y square, dz square, dxy, dyz and dzx. This is how, by using the minimum value, that is the maximum values of the L that will be started from 0 to 1, 2, 3, 4, we can easily determine to the subshells. Okay, that is the S, P, D. Remember, for the s orbital there is only 1 orbitals will be there. For the p there are 3 orbitals will be there. For the d there are 5 orbitals will be there. Similarly, if you write for the f, there are 7 orbitals will be there. There are 7 orbitals will be there. This is how we can easily determine the subshell by using the L value. By using the L value, by using the principal quantum number, we will see what is a subshell and how we will name it. Okay. If n is equal to 1, we know that the L value will be 0 and the subshell will be having a notation called as 1s. Because if L is equal to 0 means obviously the n will be become 1. So, it consists of only 1 orbital, hence it is a s orbital. Similarly, if n is equal to 2, the values of the L will be also become 2, which indicates that in the s orbital, we can fill maximum of 2 electrons, hence it is 2s. Similarly, if n is equal to 2 and L is equal to 1, we name it as a 2p. So, for the p orbitals, we can fill the maximum of 6 electron, whereas in the s orbital we can fill only 2 electron. Understood? If n is equal to 3, then values of the L will become 0 and it belongs to the 3s. Similarly, if n is equal to 3, the values of the L will become 1, it is 3p. If n is equal to 3, the values of the L will become 2 and it is named as 3d. If n is equal to 4, then it is named as 4s. If n is equal to 4, it is named as 4p. If n is equal to 4, it is known as 4d because the values of L is 2 here. The n is equal to 4 and L is equal to 3 means it belongs to the 4f. The maximum capacity to fill the d orbitals is 10. Okay, you can fill 10 electron to the d orbital. Similarly, there are 14 electrons can be filled for the f orbital. This is how we can easily determine the subshells by using azimuthal quantum numbers. Now let us move on to the next one, that is magnetic quantum number, which is also represented as a M or ML. Okay, this magnetic quantum number which gives information about the orientations of electron in a particular orbit. It gives the information about the orientations of the electron in the subshell. Each orientation corresponding to the orbital, it is therefore M1 which gives the number of orbitals in a subshell for any subshell. 2L plus values of the M1 are possible. So, how the electrons will get oriented within the subshell, that was given by the information by using magnetic quantum numbers. So, here I have the values of the magnetic quantum number by using the subshell relationship, that is 2L plus 1. Okay. Suppose if the subshell S, we have understood that it will be start with the 0, the ML value will be 0, which indicates that for the S orbitals, there are only one possibility for the S orbital and it is spherical in shape, and remember only 2 electrons can be filled here. Whereas for the P orbital, the values of the L will become 1, and here the ML value can be written in the form of 3 types, that is 0, plus 1 and minus 1. This indicates that the P orbital which having 3 possible orbitals and it is named as Px, Py and Pz, and maximally we can fill 6 electron, whereas in the S orbital there is only 1 orbital and it can be filled only 2 electron. Clear? Similarly, for the d orbitals, the L value will become 2 and ML value will become 0, plus 1, plus 2, minus 1 and minus 2. Here you can see that the d orbital can be represented with the phi orbital, that is dx square minus y square, dz square, dxy, dyz, dZx. So, maximally we can fill 10 electron in this d orbital. Similarly, if you go with the f orbital, the L value will become 3 and we can represent in a 7 orbital, that is 0, plus 1, plus 2, plus 3, minus 1, minus 2 and minus 3. So, there are 7 possible orientations will be there in this f orbitals, where the electron can be filled in a f orbital is 40. This is how, by using the magnetic quantum numbers also, we can understand how the electrons can be oriented in the each subshell. Okay. Next, here by using this, we can easily understand that S orbital will be having a spherical shape, whereas the P orbital which having a dumbbell shape, whereas the D orbital which having a double dumbbell shape, whereas the shape of the F orbital will be complicated because it having a complicated geometry. Next, we'll go for the spin quantum numbers. By using the spin quantum number, we can easily understand the spin of the electron. Usually, it has a 2 values, that is plus 1, plus half and a minus. Almost all the electron will move in an anti-clockwise direction. So, it will exhibit the plus half and a minus half values. Okay. For the S orbital, this is for the S orbital. The spin of the electron can be written as ms plus half and ms minus half, because it moves in an anti-clockwise direction. So, remember, it refers to the orientation of spin of the electron, it having the 2 values, that is a plus half and a minus half. So this spin of the electron, spin of the spin quantum number, that is the ns, that gives the information about the spin of the electron, where the electron will having a two values, that is a plus half and a minus half. Now let us move on to the next one, that is a numerical. Let's see how to solve this numerical based upon this quantum number. Okay. What is the total number of orbital associated with the principal quantum number 3? Here we need to calculate the total number of orbital. We have understood that total number of orbitals is given by the formula called as n square, where here the n is given, that is 3. Then if you apply the values of the n here, so it becomes 3 into 3. So the total number of orbital with the principal quantum number 3 is 9. So it is very simple to solve with the numerical based upon the principal quantum numbers. Next we'll see with the, by using SPDF notation, describe the orbital with the following quantum number. So we need to use a notation of SPDF. The values of the L will be 0, 1, 2 and 3. Is it right? If n is equal to 2, then L value is 1, then we call it as 2p orbital. It is 2p orbital. Similarly, if n is equal to 4, L is equal to 0. That is 4s orbital. If n is equal to 5 and L is equal to 3, so it is 5f orbital. Similarly, if n is equal to 3, L is equal to 2. So it is 3d orbital. By using this SPDF notation, we can easily describe the number of following quantum numbers by using the values of the principal quantum number along with the azimuthal quantum number. Hope you all understood with this numerical how I have solved in this case. In the next session, we are going to discuss with the shapes of an orbital. In addition to that, we are also going to understand about how to fill the electron to each orbital. That is also we are going to discuss in the next session. So in this session, we talk about only the quantum numbers, the 4 important quantum numbers, which is very important for the examination point of view, especially for the 4 marks, especially for the 3 marks, they can ask you to write the significance of 4 quantum numbers. So where you need to write importance of all 4 quantum numbers along with the notation. Hope you all understood. We'll meet you in the next session. Till that, take care and be safe. Thank you.